All right, so let's look at some examples. So identify the conic section represented by each of the following equations, then just practice what we're doing a few days ago. Rewrite the equation so that every squared variable is part of a perfect square. Basically, we're going to be completing the square, is what I mean by that. So I see on A that I've got an x squared, and that's the only variable that I have squared, so that part needs to be a part of a perfect square. Unfortunately, I do see that 8x as well, which means that I'm probably going to have to complete the square. So I am going to push everything with an x to one side and everything that does not have an x to the other. I don't care about the rest of it right now, so get it out of the way. So I'm going to have x squared minus 8x is equal to y minus 19. All right. Then mentally, I cut that -8 in half. I get -4. I square it. I get positive 16. So positive 16 is what I'm actually going to add here. Since I've actually put that in and it's not part of my original equation and I've added it to this side, I also need to counter that by adding it to that side. That way, I really just add a net of 0 to both sides, because if I was to subtract that 16 off, it would go away. I would get back to my original. All right, so then I can rewrite my left-hand side as just an x minus 4 quantity squared is equal to now just y minus 3. All right, and then I'm going to try to get my y by itself. And so I would get x minus 4 quantity squared plus 3 is equal to y. And since that y didn't have a quantity squared, that's why I left it over there. It didn't really matter to me. All right, so then I go back up and I have to identify what kind of conic section is this. Well, I only see that one of my two variables was squared, which would make that conic section a parabola. All right, on B, I see that I've got x's and y squared, so I'm probably going to rewrite this, and I'm going to get all of my x's together, and I'm probably going to leave a little bit of a gap so I can complete the square if I need to, because I do happen to see that I've got an x squared and a plain old x term, which probably means that I need to complete the square to make that part of a perfect square. And I've also got a y squared and a y, which means that I'm going to also have to complete that square as well. Fun times. All right, so I'm going to say, okay, I've got 3x squared plus 6x. I'm going to leave a gap, plus y squared minus 6y equals -3. All right, so the part that I didn't tell you guys a while back about completing the square is that in order to complete the square, you need a 1 out in front of your squared term. I almost said just y squared or x squared, but it just depends on what variable you're using. All right, so in order to just have a 1 out in front of that x squared, I would have to divide off of 3. Well, since I'm just dealing with my x's in that 3, I'm just going to pull that 3 out of my x's. So I'm just left with x squared, now plus 2x quantity. And that y squared has a 1 out in front of it, so it can just stay chilling for a second. All right. So now I'm going to slice and square over for my x's. So slice that 2 in half, I get 1, and then I square it, so I'm going to add 1, or I want to add 1. But since 1 is the only thing I've really added here, I also need to add it to the other side, but then I have to take into account, in order to complete the square, I had to multiply by 3. So I actually need to add 3 to the other side for that particular junction. All right, and then I need to complete the square for my y's as well. So I'm going to look at my number out in front of my plain old y. I'm going to cut that in half, which is -3. I'm going to square that, which is positive 9. This time I don't need to worry about distributing. I just need to add 9. That's it. That's all. All right, so now I can rewrite my left-hand side like 3 times x plus 1 quantity squared plus y minus 3 quantity squared equals positive 9. All right, so this time I see that I don't have a parabola because I don't just have one variable squared, unfortunately, which would make it super easy. I do notice that I've got 2 coefficients. One's a 3 and one's a 1 out in front of that y. If you need to write it, go ahead and put it. So I notice that my coefficients don't match, which would make it a circle. However, both of my variables are squared, their signs match, but their coefficients are different. One of them's a 3, one of them's a 1, which would make this bad boy an ellipse. Easy. maybe not. After you've done the hard part, identifying these shouldn't be so bad. Alright. See you guys in my next video, probably.